I'm Michelle. I'm the AP Calc teacher here at Boston Collegiate Charter School in Dorchester, Mass. Boston. So this PowerPoint is, so I'm calling it limit definition. This isn't really a separate topic so much as a specific problem type that uses a lot of different skills that you've learned. And so if you recognize this problem type, yeah, just like this will help you synthesize a lot of different things together. I think that otherwise would be difficult. All right, so we're going to be applying the limit definition. So here's the problem. All right, what is this expression? What's its, what is it? So let's take a, what's it equal to? So let's take a second. Our go-to is to substitute in 0 for my h's. If I do that, I will get 0 over 0. Okay. Now I know we recently learned L'Hopital's rule, and we know lots of other things to do. We're not going to apply any of those. We're going to apply one more item to it, and that's the that you should recognize this as something. So take a sec. You're going to enter in. What does this remind you? This structure should remind you of something. It should remind you of something. All right. So this should remind you the definition of a derivative. So let's review one of the two definitions of a derivative we learned. Definition, this was the first primary one of a derivative. Okay. The definition of a derivative, to review, is the limit as h approaches 0. So h is the distance between these 2 points. We want the distance between 2 points to approach 0. That's when my secant line is becoming a tangent line of f of my second point has a y value of f of x plus h, because h away from f of x, minus f of x over h. Again, on the bottom, this is h plus x minus x. This is really y2 minus y1 over x2 minus x1. And we could do the whole diagram, but we've already talked about that a couple times. But this is y2 minus y1 over x2 minus x1. This is some stuff that cancels. The x is at the bottom. So that's the definition of a derivative. So when you're doing this, I'm going to toggle back and forth between this and our steps. The first thing you want to do after you recognize this is the definition of a derivative problem. Let's do some steps. Oops. Let's do some steps. Is number 1. Tell me what is f of x? That's our first step. What is f of x? What is f of x? Oops. So if we go back here, all right, if we look here, f of x, so there's not going to be any h's in here. In this problem, f of x, and the more you do these, the more you'll recognize it, is 8. The inside, so right now x is not a half is going to be put in for x, we'll find out later. But f of x is 8. 8x to the 8. It's actually easiest since the definition has f of x plus h minus f of x. Since this is actually, since the second term is f of x, it's easiest to look at this term right here to figure out what f of x is. All right. Now, let's talk about what's up with that half, okay? So let's do step number 2. Is x being evaluated at a constant? Okay, some problems you'll have x's, like the whole problem will deal with x's. Sometimes x will be actually evaluated at a problem. So let's look at this. This, in fact, isn't f of x. This is f of 1/2. So for this problem, I'll make notes of step 1. F of x is 8x to the 8th, and then x equals 1/2. So you can tell there that that's not, this is not 8x to the 8th, this is 8.5 to the 8th. So x is 1/2 for this problem. Okay? Now, it seems like we've done so much work already, but we actually haven't done the crux of the problem. Since this is telling us the definition of a derivative, right? How I'm going to evaluate this is I'm actually going to take its derivative. So step 3, we take the derivative. take the derivative. So right here, take a second. If this is f of x, f prime of x, take a sec, find f prime of x. F prime of x is 64x to the 7th. All right. Now, of course, sometimes you'll be done. Like if the problem, sometimes that was the answer. Great. But this one goes a step further. What do you suppose the last step is? What do you have to do? I haven't used the 1/2 yet. Right. So the last step, if needed, is sub in the value for x. So that's our final step. So on those steps, that's our final step. And now from here, so f prime of 1/2 equals 64 1/2 to the 7th, 1/2 to the 7th. Take a second to figure it out. Actually, you don't really need to do it out. I would do 64, so if you have 2, 4, 8, 16, 32, 64, this is 2 to the 6th times 1 over 2 to the 7th. If you did 2 to the 7th, it's 128. But if you do it this way, it's a little bit quicker. So 7 minus 6 is 1, so you have 2 first on the bottom, which is B. So the answer is 1/2, which is B. Alright, and so we have our steps here. This is what you're going to refer to for all of them. I'll leave them up on the side. Alright, this is APQ2. So here are the answers. E says non-existent, so I'm switching to read there. Oh, we haven't learned how to do elements. Okay. Alright, we're going to skip this problem. Don't worry about it. Alright, this problem we can do. Alright, so take a look at this. The limit as h approaches 0 of 3 parentheses x plus h minus tangent of 3x all over h. Okay. So notice that this problem doesn't have any constants. You have your x's in it. So the first thing you want to do is recognize that this is the definition of derivative. Limit as h approaches 0, that's the giveaway here. Limit as h approaches 0 of so f of x plus h minus f of x over h. So go ahead, go through these steps, figure out what is f of x, and then is x being evaluated a constant? For this one, it's a no. So you can skip step 2. So then you're going to take the derivative, and then you don't need to substitute in for x because there is no constant there. All right, the derivative is kind of a little bit tricky, so be careful. So pause the video, find the answer, select it, and we'll come back together. All right, let's do it together. So my function here again, that's typically your f of x. I mean, that's exactly where your f of x goes in the definition of derivative. So f of x is tangent of 3x. All right, since that's an x, there's not a constant to substitute in. We don't have to worry about that. It's the definition of the derivative. So we do, in fact, need to take the derivative. This is, think about what rule you need to apply. The chain rule. So you can put parentheses there if that's helpful. So tangent's my outside, 3x is my inside. The derivative of tangent, hopefully you have it memorized. If not, hopefully these sort of triggered your mind. Secant squared, it stays the same. And multiply by 3. That's it, that's the answer. Oops. But yeah, that's it. It's B. It's B. Alrighty, let's do this guy. Let f be a function such that the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h equals 5. Which of the following must be true? F is continuous at x equals 2, f is differentiable at x equals 2, the derivative of f is continuous at x equals 2. So take a minute, try to think this out, and we'll go over it together. Alright, let's go over it. The answer is C. 1 and 2 are correct, 3 is not. So this basically means that in words, that the derivative of f at 2 is 5. Okay? So that means the derivative has to exist because it's 5. It's a number. So that means the derivative exists and is a number. So that means that it's differentiable because the derivative exists. Okay. That's what differentiable means, the derivative exists. Since it's 5, it exists, it is differentiable. If you have a differentiable function, you automatically must be continuous for the derivative to exist. Since 1 is true. For 3, the derivative is continuous at 2. We don't know if the derivative is continuous at 2 or not. Like the derivative, for instance, the graph of the derivative could look something like this. I'm graphing the derivative now, f prime of x. So at 2, 5 totally exists. 2, 5 is there, maybe it's a line, and then it's something else. So all it's saying is that the derivative here, that the derivative's value at 2 is 5, but I don't know if it's continuous or not. So you can have a value at a point you defined, but not be continuous. All right, thanks. This is Michelle from Boston Collegiate Charter School. Check out my website on offonthetangent.weebly.com.